Right. Is there anybody who would like to make a contribution or ask a question? These three wise men. A brief one, of course. Have we any hands showing? There's one over there. Could you please identify yourself and then say it?
Yeah, I'm Nick Reed from TRL. Questions for Richard. You talked about using AI to provide advice, but the system was called a strategic commander, and there seems to be kind of a difference between something that commands and something that advises. I just wondered if you had any comment on that.
Hi, the strategic commander, I was referring to the role of the model. So we need to get models working in a second, and we see the tools from AI able to make those models, which probably will be a link-based model, and everything that's happening all over the place, millions and millions of variables, we'll be able to understand what the flow or the speed would be on that link at that time. So the reference to AI was more about the model rather than giving advice. The advice would then come out of the model, with the model running in several seconds, maybe trying lots of different scenarios, city settings, that sort of thing.
Good, thank you. I think I saw a hand over here. Yes, there's a mic.
Hello. Yes, question for Martin.
Who are you, please?
Sorry, I'm Sam Lee from ACOM. There's a question for Martin in terms of modelling. You talked a little bit about understanding people's emotions and how they feel about their particular experience. Are you looking at creating some sort of standard in order to capture that? You know, not just for your particular VR model for automated vehicles, but for other things as well in the future. And what do you feel the biggest challenges will be for that? Thanks.
So, yes, I'm not looking to create a standard. I'm looking to learn and use technologies that are out there already. Having worked in the Centre for Human Sciences at Kinetic, where they had a laboratory full of sensors and so on, I knew we couldn't really afford that level of investment. But with the wonderful thing about technology, costs come down and capability goes up. And I've actually managed to get hold of a system called a Bitolino. It's from a company in Portugal, and it allows you to measure physiological responses. So we've got respiration, heart rate, epidermal changes, and we can also do eye tracking inside virtual reality. So as we run user trials in virtual reality, we can actually capture people's physiological responses. And we can also compare those against their subjective experiences. So between those two elements, we can actually get some meaningful data out of running user trials in VR. Obviously, this is early days, but the signs at the moment are looking very positive for being able to get subjects and get meaningful data from those types of activities.
All right, here's one here, please.
Larry Faulkner from Cogitare. You've been talking to us about some very, very detailed modelling down to the individual, which sounds to me like quite a complex model to validate. So the question for you is twofold. How complex should a model be in order to give the information we need? And when do you think we need to go down to the modelling of every individual and one-to-one to solve the problem?
Could we start with John on this one?
This is the sort of question that comes up, relatively regularly. And I think it's an important question to ask, because there is no point in going beyond a level of detail that is useful, and it can actually introduce quite a lot of uncertainty into models that is not necessary. However, I think that there are certain kind of like systems that it's certainly worth exploring. How detailed models replicate the results that we see from less detailed models. And I think that, when we look at agent-based modeling, which is a field that very much sort of centers on the way that sort of individuals interact in a model, I think that we start to see very interesting insights about the way those systems behave as a whole. So I think that there is definitely value in doing it. Validating models of extreme sort of scale and complexity obviously is challenging, not least of which because you need to have some sort of data to calibrate and validate those models against, and collecting that data is often quite expensive and difficult to do. However, by kind of leaning on pre-validated technologies, and this is kind of something that I think is kind of very sort of integral to how modelers can make use of something like Spatial OS to achieve scale. You deal with models that have already been validated, people already trust them. And so by using those and inheriting their kind of validity, you can start to have more confidence in the sort of large-scale simulations that are built up as a composite of them.
Okay, thank you. I've seen a hand from Brian here in the front row.
Thank you. One of the properties of medical science is we're all living a lot longer, and yet a lot of our capabilities are diminishing. They're not diminishing to zero, but they're not as good as they are when you're younger. So I just wonder, when you end up with 30, 40, 50% of the population being what is above what is now regarded as normal working age and is diminishing in its capability, its own physiological capability and mental capability, is anyone looking at the use of the modeling techniques in augmented reality in particular to see whether you can do restorative capability in order to keep those people socially, economically, physiologically active? Because if we don't, they become a huge burden on us economically. And if you do, then that may have some really profound benefits. And in a developed world where that fraction of the population is going to go up into many tens of percent, it does strike me we have an opportunity to do something about it. Maybe special plea for me, of course.
I think that's for Martin. Yeah.
I don't mind who answers the question, but it does strike me that we've talked about the whole game so far has been about modelling the world for able-bodied people, if I can use that phrase, but it's not only able-bodied, but it's able mentally. And we know that we're doing a fantastic job in looking after people's physiology. We're not doing too fantastic a job as yet on looking after their mental capability. So augmented reality could actually be restorative capability by having everything you thought you'd forgotten restored to you very quickly, because you've got enough cues to know where to find it, but you can't find it. But somewhere out there in the cloud, it'll get found for you fast enough for you to then navigate, to drive, to find what you want to find, whatever. And those are the sorts of things that we know people are suffering from when their normal physiological and mental capabilities start diminishing.
Are you thinking of people like you and me, Brian, our sort of age?
I did slip in there. I did have a personal interest. But no one heard that. I don't know why. Is everyone deaf in this
I was
room?
just a gog.
Yeah.
Martin.
So this is something that is really, really important to me. The potential for designing products better by understanding the limitations of certain parts of society will make products better for everybody. And we're very lucky at the Catapult. We get a huge range of people through our doors interested in what they can learn about transport and what they can bring to transport. And one of those key meetings, chance meetings, was with the RNIB. We just presented at the Tech Share, which is a Google event, but it's sponsored by the RNIB, to showcase a product we've made called Eyewear. So this is an app which works on your phone, which recreates visual impairments. And this is done as a bit of an exploratory project to see how we could recreate visual impairments. But it's actually generated a tool which will be incredibly useful for designing products for people with visual impairments, allowing designers and engineers, through the use of a Google Cardboard or a VR headset, to review their product or their environment and improve it based on better understanding and seeing through the eyes of other people who have eyesight which has been diminished. And we're not talking about only serious visual impairments, but anything from short-sighted, long-sightedness, colour blindness, things that a very large number of the population are afflicted with. The other thing that really rang out, and I think something with autonomous vehicles that hasn't been really focused on, is okay, the technology, getting it to work is massively challenging. There's no denying that. Getting the computer to recognise the environment and make an appropriate response is very important. But now I think we need to really focus on the users. Who are we selling to? What are the service, the models that we're offering out to the public? Is it ownership? Is it rental? Is it on demand? Is it dynamic? And that's where I think modelling is going to be hugely valuable in understanding what it is that we need to provide to different parts of society. How will they look? How will they feel? What are the limitations of people? Some people might not be willing to pick up a smartphone, so what alternatives are there? So there's a huge amount of work in that space, and it's something that we're very, very interested in.
So I think the answer is yes. I saw Anand here in the front. I think we've only got time for this one now, but there'll be a chance later as well.
I'll keep my question short. Anand Alos Atkins to John. You talked about your simulation, and this reminds me of the activity-based modeling that Rick was talking about. Obviously, they do lots more in America than we do down here, but the whole purpose of it is to model every individual. So for London, you'd be actually modeling 8 million people. I believe in granularity, and you can demonstrate that the more granular your analysis is, the more robust it's likely to be. So if I don't care as much about electricity and water, how is your simulation different from ABM, John?
Well, I would say it's kind of not. I mean, we're talking really a platform that enables large-scale ABM, large-scale agent-based modeling, and things like that. So, you know, this is just a modeling tool, and there is a massive range of different simulations that could be created using this platform. What we do is really to make it extremely easy to utilize massive amounts of computing power and to remove those concerns about, you know, how do we parallelize it, how do we optimize the processing, how do we distribute workload, how do we deal with resilience when you know, maybe one of the physical machines that runs a simulation falls over. So I'd say, is what we're doing different? No, I think hopefully it's entirely complementary, and hopefully our platform is the kind of platform that can allow people doing that kind of large-scale, very granular modeling to focus on the modeling rather than making the computers work, because we've got a team of specialists at making the computers work, and we have kind of packaged that up into a platform that is available to modelers to produce agent-based models, activity-based models, etc.
Right. Okay, before we break, could I just suggest that you don't leave after this. We've got 3 more excellent speakers, then we've got a very good panel of experts afterwards, and then we've got free drinks and food, so it's really worth staying. We're going to break for 15 minutes, and then we're getting some of the time back. Could I ask you to thank the 3 speakers?